Here we go. A little more about forklifts. This is Appendix A, and it's about stability. Why we're going to talk about this? Because stability is extremely important. It's one of the biggest problems with forklifts is they tip over because people don't understand the stability of the forklift, and because it's kind of like on a triangle, and we'll explain it. It makes it way different than you would think for way different than a four-wheel vehicle, and most of us drive four-wheel vehicles. So let's go look at this and you'll probably understand the idea. This is one of those non-mandatories, kind of a guideline. Some things, like I said before, these appendices should be read because they frequently have some good information in them, and they're usually not, as dry as the standards. So this Appendix A, stability of powered industrial trucks, non-mandatory Appendix A to paragraph L of this section. So this is kind of an appendix to even just one paragraph. So anyway, there's some definitions in here too. That's a good reason to have it too. So to help explain the principles of stability, and I don't mean stability in your home or anything like that, only of the forklift we're talking about here. Center of gravity is the point on an object at which all the object's weight is concentrated. For symmetrical loads, center of gravity is in the middle of the load. So for symmetrical, it means the same on all sides. If you have a box, it's 2 foot by 2 foot by 2 foot, and the same weight throughout the box, then it's going to be right in the middle. So counterweight is the weight that is built into the truck's basic structure and is used to offset the load's weight and to maximize the vehicle's resistance to tipping over. That's that big old weight in the back. Fulcrum is the truck's axis of rotation when it tips over. Usually that's the front wheels. Grade is the slope of a surface, which is usually measured as the number of feet of rise or fall over 100-foot horizontal distance, which gives you a percent. For example, if your lawnmower's instructions tell you, I think, don't mow sideways over a slope of 15%. So that would be 15 feet of slope, 15 height difference over 100 feet. So lateral stability is a truck's resistance to overturning sideways. Line of action is an imaginary vertical line through an object's center of gravity. Load center is the horizontal distance from the load's edge or the forks or other attachments, vertical face, to the line of action through the load's center of gravity. So longitudinal stability is a truck's resistance to overturning forward or rearward. It's kind of hard for it to go rearward. I've never seen when that happen. I'll go forward, yes, but moment is the product of the object's weight times the distance from a fixed point, usually the fulcrum. In the case of a powered industrial truck, the distance is measured from the point at which the truck will tip over to the object's line of action. The distance is always measured perpendicular to the line of action. Track is the distance between the wheels on the same axle of the truck. Wheelbase is the distance between the center line of the wheel's front and rear wheels. And your car has a wheelbase too. General, determining the stability of a powered industrial truck is simple once a few basic principles are understood. There are many factors that contribute to a vehicle's stability: the vehicle's wheelbase, track, and height, the load's weight distribution, and the vehicle's counterweight location, if the vehicle is so equipped. The stability triangle used in most stability discussions demonstrates stability simply. Basic principles: whether an object is stable depends on the object's moment at one end of a system being greater than or equal to or smaller than the object's moment at the system's other end. This principle can be seen in the way the seesaw or teeter-totter works. That is, if the product of the load and distance from the fulcrum, the moment, is equal to the moment at the device's other end, the device is balanced and it will not move. However, if there is greater moment at one end of the device will try to move downward at the end with a greater moment. So that's a good way of explaining it. The longitudinal stability of a counterbalanced powered industrial truck depends on the vehicle's moment and the load's moment. In other words, if the mathematic product of the load moment, the distance from the front wheels, the approximate point at which the vehicle would tip forward, to the load's center of gravity times the load's weight is less than the vehicle's moment, the system is balanced and will not tip forward. However, if the load's moment is greater than the vehicle's movement, the greater load moment will force the truck to tip forward. The stability triangle. Almost all counterbalance powered industrial trucks have a 3-point suspension system. That is, the vehicle is supported at 3 points. This is true even if the vehicle has 4 wheels. The truck's steer axle is attached to the truck by a pivot pin in the axle center. When the points are connected with imaginary lines, this 3-point support forms a triangle called the stability triangle. Figure 1 depicts the stability triangle. This is right out of your book, so you can look at it too there. So here's your unloaded, your vehicle center of gravity is right there in that the round figure there, the black round one. Center of gravity. The vehicle is the oval round black spot. And it says, note, when the vehicle is loaded, the combined center of gravity, CG, shifts toward line BC. Line BC, of course, is the front wheels. Theoretically, the maximal load will result in a CG at the line BC. In actual practice, the combined CG should never be at the line BC. The addition of additional counterweight will cause the truck's center of gravity to shift toward point A, result in a truck that is less stable laterally. And it's laterally because of that triangle. So if you had if it was 4 wheels were the same and didn't have that center point at the back wheels, you wouldn't have a triangle. It'd be different, but you have that triangle. So if that vehicle center of gravity gets outside that triangle, it's going over. There ain't nothing you can do about it. When the vehicle's line of action or load center falls within the stability triangle, the vehicle's stable and it won't tip over. However, when the vehicle's line of action or the vehicle load combination falls outside the stability triangle, the vehicle's unstable and may tip over. Just about has to tip over. So in other words, if the vehicle's stable because your load center of gravity there is, and your combined center of gravity, the load center of gravity is, combined center of gravity is are both inside, they're both inside the stability triangle. That's what it is. Yeah. The line, there's your line of action. So now if the load center of gravity gets outside of it, it's going to go over your load center of gravity. You can see the higher you get, the better chance of that happening, because the higher you get, the less change at the base is going to make a bigger change at the top. Longitudinal stability, the axis of rotation when a truck tips forward is the front wheel's point of contact with the pavement. When the powered industrial truck tips forward, the truck will rotate about this line. When a truck is stable, the vehicle moment must exceed the load moment. As long as the vehicle moment is equal to or exceeds the load moment, the vehicle will not tip over. On the other hand, if the load moment slightly exceeds the vehicle moment, the truck will begin to tip forward, thereby causing the rear to lose contact with the floor or ground and resulting in loss of steering control. If the load moment greatly exceeds the vehicle moment, the truck will tip forward. To determine the maximum safe load moment, the truck manufacturer normally rates the truck at a maximum load at a given distance from the front face of the forks. The specified distance from the front face of the forks to the line of action of the load is commonly called the load center. Because larger trucks normally handle loads that are physically larger, these vehicles have greater load centers. Trucks with a capacity of 30,000 pounds or less are normally rated at a given load weight at a 24-inch load center. Trucks with a capacity greater than 30,000 pounds are normally rated at a given load weight at 36 or 48-inch load center. To safely operate the vehicle, the operator should always check the data plate to determine the maximum allowable weight at the rated load center, and that will be on the data plate. Although the true load moment distance is measured from the front wheels, this distance is greater than the distance from the front face of the forks. Calculating the maximum allowable load moment using the load center distance always provides a lower load moment than the truck was designed to handle. When handling unusual loads, such as those that are larger than 40 inches long, the center of gravity is greater than 24 inches, or that have an offset center of gravity, etc., a maximum allowable load moment should be calculated and used to determine whether a load can be safely handled. For example, if an operator is operating a 3,000 capacity lift truck with a 24-inch load center, the maximum allowable load moment is 72,000 inch-pounds, 3,000 times 24. If a load is 60 inches long, which would give you a 30-inch load center, then the maximum that this load can weigh is 2,400 pounds, because that's 72,000 divided by 30. Lateral stability. The vehicle's lateral stability is determined by the line of action's position, a vertical line that passes through the combined vehicles and load's center of gravity, relative to the stability triangle. When the vehicle is not loaded, the truck's center of gravity location is the only factor to be considered in determining the truck's stability. If it's not stable when it's not loaded, you got a problem when it's loaded. As long as the line of action of the combined vehicles and load's center of gravity falls within the stability triangle, the truck is stable and will not tip over. However, if the line of action falls outside the stability triangle, the truck is not stable and may tip over. Refer to figure 2. Factors that affect the vehicle's lateral stability include the load's placement on the truck, the height of the load above the surface on which the vehicle is operating, and the vehicle's degree of lean. In other words, if you're going around turn. Up to this point, the stability of a powered industrial truck has been discussed without considering the dynamic forces that result when the vehicle and load are put into motion. The weights transfer and the resultant shift in the center of gravity due to the dynamic forces created when the machine is moving, braking, cornering, lifting, tilting, and lowering loads, etc., are important stability considerations. When determining whether a load can be safely handled, the operator should exercise extra caution when handling loads that cause the vehicle to approach its maximum design characteristics. For example, if an operator must handle a maximum load, the load should be carried at the lowest possible position. The truck should be accelerated slowly and evenly, and the forks should be tilted forward cautiously. However, no precise rules can be formulated to cover all these eventualities. And that's about it. But stability on forklifts is extremely important because obviously you don't want your forklift to tip over for a lot of reasons. Number one, what else it's going to hit? Who else it might hit? And if it's tipping over, I mean, there's a load, and that load's going to come down somewhere, and it's going to do some damage to somebody or something, and certainly to the load. So it's handled too a little bit in this video that's also included in this. And watch that video too, because there's good information in that. And in fact, there may be more than one video that's watching this thing. So anyhow, drive them forklifts carefully. Be safe.